Hello there, this is Douglas Rumbaugh. A while back, I published a video which was effectively just me writing a bash script, and that video actually seemed to do pretty well. So I'm going to do it again. I'm in a situation now where I'm going to be writing a script for something anyway, so I figured I'd obscure what I'm doing slightly, record a video, and see how we do. So in this video, I'm going to be writing a not super complicated, but perhaps a little bit tricky bash script for doing some plotting. So let me show you exactly what it is that I need to do first, and then we'll talk a little bit about how I intend to do it. So I have data files that are formatted something like this. Each pair of lines, so this right here would be, say, a pair of lines in this file, is associated with a particular experiment and contains some data that is associated with that experiment. In particular, what I would like to do is create two plots, one plot using this number and one plot using this number, where the x values are the first one here, so 35, 4045, and this second column here gives the series. So there's going to be one series for 5,000, one series for 10,000, and so on. You can see how this is not super complicated in principle, but in terms of like getting from here to where I need to be, a little bit complicated. So I think a script is going to be the best approach here. I might be able to make it all work in a single processing pipeline, but that seems rather unlikely. So we're just going to go ahead and do a script. Now, to show you what I'm doing right now, I am effectively manually splitting this data out into files, which look something like this. So that this set of one files here corresponds to that first number that I want. And then the two series corresponds to that maximum number as well that I want. And this digit here is basically the series number. So you can see the series 0 has the 5,000s, series 1 has the 10,000s, and so on. And I've put together just a little GNU plot script, which is going to produce a plot that looks like this based on that data. So this is the end goal, is to write a script which takes that file as input and gives me two of these plots. This is the one for that first number, and then another plot for the maximum number as well. And I'm content to have to go in and manually tweak certain things to get, say, the axis scaling looking reasonable and things like that. I can do that manually, but I want the basic generation of these files and of, say, a first draft of these plots to be largely automated. So that's what we're going to be attempting to do. Again, remembering that we're starting with this file as our input to this whole process. When I'm writing a bash script, what I tend to do is hack around on the command line interactively for a little bit in order to get a feel for what commands I need to do the thing that I need to do, and verify manually that all of these commands are working properly, and then string them together into the form of a script. So I have this commands.txt file over here where I'm going to be simply recording the commands that I come up with as I come up with them to do this processing. And then we'll take this commands.txt file and use it as the basis for our script whenever we're done with the whole thing. So what I think I'm going to do to get started is take this one file and split it into two. So I'm going to segregate a file for what I'm going to call these type 1 lines, and a corresponding file for the type 2 lines as well. And in order to do this filtering, I'm going to just use sed. I should point out that I'm going to be using quite extensively the core utilities as part of doing this, rather than using pure bash. Bash has this necessary string manipulation stuff built in to do a lot of what I want to do here, probably all of it. But I don't know that very well, so I'm going to stick with the tools that I know because I would like to actually finish this at some point tonight. Realistically, doing this inside of bash purely would perhaps result in a script that is a little bit faster. But let's be honest, even if the performance difference is on the order of a couple of seconds, it's still worth it for me to pay that cost and do it using the core utilities instead, because that's what I know. And frankly, the performance cost is not going to be on the order of seconds. I dare say you wouldn't even notice it, most likely. till all the GNU plot stuff that I'm going to be using is done. So we're going to be using core utilities. That's the kind of video this is going to be. I'm sorry if you were looking for pure bash, but you may want to just move on at this point because you'll probably find the rest of what happens here kind of ugly. In any case, first things first, and I'm just going to use cat to get this data flowing for my little trials. I'm obviously not going to do that in the scripts themselves, so don't judge me too much for that. We'll start by using sed tac n in order to filter out all of the type 2 lines. Now, the way that this tac n flag for sed works is that it makes it so that it only prints the lines that you tell it to print. So what I've just done here is I've said, if the line has count in it, effectively, and frankly, I don't even need this dot star, probably I could just do that. If the line has the word count in it, which only these type 2 lines do, then print it, otherwise don't. If I hadn't used this tac n flag, then sed would default to printing everything, and so we would see the count lines twice, effectively, and then everything else would still be there. So if we do this, that's going to turn off the default print, and we are only going to see those prints that I tell it to do. So we're going ahead and do that, and let's just call that type2.tsv. And I can do a similar sort of filtering for the type 1 lines. If we take a look at those, you can see that my type 1 lines have a number as their first column. So we can look for that and use it to print. What that's going to look like is I'm going to do, again, a tac n, and I'll also add r because I'm going to use an extended regular expression for this. It's not really necessary, but I'll do it. It would help if I also used the word sed. If you're not familiar with what this r flag does, it gives sed access to a richer set of operators for its regular expressions. We'll see this a little bit later because I think I'm going to use back references for something which tac r turns on. In this case, I'm going to use a plus sign in this regular expression. I think it's probably not strictly necessary, but hell, I'll do it just to demonstrate. So we need this r flag to enable that. And we want the line to start with digits. So we'll use the POSIX character class here to specify digit, and the plus, which works similar to a star, except the plus requires there to be something that matches it. So if I were to do this, what that would say is the line must start with 0 or more digits, but it can't start with, say, a letter or whatever. But if I do this, it requires the line to start with 1 or more digits. So we're requiring that, requiring at least 1. This would theoretically filter out blank lines. There aren't any, but what the heck, we'll just do it anyway. And I think that should be it. So if we just do that, now we get all of our type 2 lines correct. Okay. And just to be clear, the star... oh no, wait, that star doesn't work. Interesting. I would have figured the star would work, but okay, so we need the plus. Cool. And so we'll just pipe that to a type1.tsv file like so. All right, so now we have our type 1 file, which has those first lines, and our type 2, which has the second. Now, the next thing I'm going to do is just to clean this type 2 file up, because right now there's a bunch of words and letters and stuff I don't want. The only thing that I care about in this file is this max number. So I'm going to use sed, I think, to filter it out so that I only see this max number. I could actually use awk for this and it might be a little bit cleaner, but we'll use sed because I should be able to get this to work. So the basic idea for what I want to do here is I'm going to cat this file into sed, and we'll go ahead and use r again. And what I'm going to do is I'm going to do a substitution. So I want to substitute lines which contain max colon and then the digit. And this digit is going to correspond to the number, right? So I need digit colon bracket star, so any number of digits, and then the end of the line, like that. So now the thing is, if I do this right now and say, like, substitute this for, say, t, and put this in brackets, what I suspect should happen is, yeah, so we're replacing the whole line with that t, right? Because what sed does is it finds the thing that matches and replaces it with this. So this is actually what I want. I want to replace the whole line. If I say got rid of this and just said max colon digit whatever, you'll see what that does is that just replaces the max and the bit with the t. I want to replace the whole line, so I need to do this dot star. The question is, what do I replace it with? And for this, what I'm going to do is I'm going to use a back reference. So if I group this number in parentheses like this, these parentheses you can use in regular expressions to group things. So now I'm going to be referring to all of those numbers as a group. And when you're using sed with this R flag, you can use back references, which in sed you use a backslash followed by a number. And what's going to happen then is this \1 is going to correspond to whatever this first parenthetical regular expression matched to. So as you can see, if I run that command now with the back reference in place, it replaces the whole line with just the number that I want, which is good. So at this point, I've done a whole bunch of stuff. Let's go back through my history and just dump all of this stuff into this commands file so I don't lose track of it. Okay, so just went through and copied those guys out of our history. Those are the 3 commands that we have and what they're doing. Okay, so the next thing that I think I want to do is I now have these guys separated out. If we look at my type 2 data here in the manual, you can see what I've done is I've attached, of course, the series number, which is this guy, and the x value into those files as well, which is going to be useful for plotting it. So let's go ahead and do that next. And this is the sort of thing where the cut and paste commands work really well. So if I take type 1, which has these numbers that I need, and I use the cut command, I can extract just the first 2 fields from it, like that. So cut is going to, by default, use white space delimited columns. You can actually, it's a really handy command. You can specify whatever delimiters you like. In this case, I'm using tabs, so it all just works. And you specify the fields you want, and it just gives you those fields. Now, this works really well with a command called paste, which is going to basically append files together column-wise. So what that's going to look like is if I cut those fields that I want out of the type 1 file, and I paste standard input with my type 2 file, you can see that gives us this. It takes those guys and it sticks them at the beginning of the contents of type 2. So this is the first 2 fields from type 1 file. This is the type 2 file. Now, of course, I actually don't want to stick it on type 2. I just need this number. So what I should do is I should actually go back, run that sed command here, this guy. Let's dump that to, say, type 2 proc. We'll dump that to a file. And then we can go ahead and run this, where'd it go? There we go. And use the type 2 proc file for that. And so there we go. That gets us our type 2 file properly formatted. And let's just call that type 2 and overwrite the old one. And we can get rid of the type 2 proc. Okay, so now we have type 1 looks like that, which is just the data we want to plot. And type 2 looks like that, which is just the data we want to plot. So let's go ahead and drop this thing into our commands as well. So now we have our 2 files split out from our main one, each one of them with all of the data we need. The next step, I think, is going to be, if we take a look at the way I did this manually, you can see I have 1 file per series. Just because of the way that I have this data laid out, that makes the most sense for me from a GNU plot standpoint. If all of the series had the same X values, then I could actually very easily just use 1 file. But because each of these series has different X values, it's a lot easier just to use separate files for each series. I'm sure that there's a better way of doing this within GNU plot, but I'm not exactly a GNU plot wizard. So we'll just leave it we'll just keep this same model going because realistically we're using a script anyway, so who cares how many files you have? As a result, what I need to do is I need to identify what the series values are, and then go through each of these files and split all of the records matching each series number out. So I should have a file with all the 5,000s, a file with all the 10,000s, 20,000s, 50,000s, whatever. However, I also want this to be general to the number of and specific values of those series. So right now I'm using 5, 10, 20, 50, but I may want to use other values for those at some point. So we'll be slightly generic for that. And I'm thinking if I want to get the specific series that I have, the specific values for the series, I can actually use cut for that too. So if I use cut F2, that'll cut the second field. So let's just go the original data, doesn't really matter, and cut F2. Actually, no, I shouldn't do that. I should use type 1. There we go. And now I can sort and unique that. And so that should get me each individual series number. That's good. And I'm thinking, if I recall how this works correctly, I should be able to just do something like this. I think that those line breaks are going to give me like a separator that the for loop will automatically tokenize on. So let's just test that. If I say $I, or no, it should be $S, damn it. So for that, do echo $S, done. It occurs to me, I have no way of knowing if that was a loop that ran one time or a loop that ran multiple times. So let me do this. 5,000 test. Okay, good. Great. So this loop then is going to iterate over each of the field values. And so what I'm thinking is, if I do that, and for testing purposes, let me just set x equal to, say, 5,000, rather than having to do all this loop shenanigans here manually. I said 5,000, not 500. I think I can use the same sed trick that I used up here to filter these things. So if I do, what would that look like? Let's cat type 1 into sed. We'll use the same nr. And I want to match the second column. So I need my first column, which is going to be some sequence of digits required, followed by a tab, followed by my second column, which needs to exactly match 5,000, followed by a tab, followed by the rest of the line. So that'd be a dot star $, and print those. So theoretically, this should just give me the 5,000 lines. No, because I need to put a slash there to begin the command. Okay, good. So that gives me the 5,000 lines. And so what I should be able to do then is switch this 5,000 for the variable s, which I set, or x here, I guess, which I set to be 5,000. This isn't going to work because I'm using single quotes, which disables variable expansion. So we'll re-enable variable expansion, and hopefully this $sign here doesn't mess anything up. I guess I could escape it if I needed to, but doesn't look like I need to. That's going to work. Okay. So then what I'm thinking is I can do something like this sed command, where this $x is a $s, and then pipe it to a file of some kind. I think we now have everything we need in order to at least set up the files to feed into my GNU plot script. And I've already actually written the GNU plot command. That just looks like this. So you can see I'm plotting each file individually, and I have the titles hard-coded and whatever. We can automate this. I'm thinking I can actually use a a for loop or something to automatically generate this plot command for however many series we need. But we may or may not actually do that in this video because we'll probably be getting a little bit long at this point. I may do a follow-up dealing with the plotting itself. But let's actually get the script going to at least create all of these files here. So we'll call this plotscript.sh. We'll just run it in bash. For convenience, rather than taking the data file on standard input, I'll just take a file name as the first argument. So what that means then is that for our first command, we are going to want to filter out all of those type 1 records, which is going to be this guy. So we can paste that guy in here, and we will use $1 as the file name there. That'll get us our type 1 files. Likewise, for our type 2. Okay. Next up, we want to do the filtering here. And actually, it occurs to me, I can do this a little bit more conveniently by doing this. So we'll just use two sed commands connected by a pipe. Now, there's almost certainly a way to get these two sed commands condensed down to one sed command. I don't 100% know how to do that, though. It's not as simple as just placing this followed by this, because even though this command says print the line, the second rule will be evaluated on lines, even those that don't match this first rule. So we'll just go ahead and do it this way for now. It occurs to me I could actually most likely use this. In fact, let me try that. Sorry, I'm going off script here, but I want to go back and revise this because I think there's a better way of doing it. If I do this command, cat data.tsv, pipe that into this command, that will do that. All right, so it's printing everything out. But I think if I do an rn there, that'll disable the default echo, and so we see nothing. And then if I put a p here, perfect. Okay, so this one sed command will actually do the work of both of those. And so just to be clear as to what I'm doing here, to merge these commands together, what I've basically done is said, I'm doing the same substitution that I was. However, I'm explicitly printing the result and then not printing anything else. So this one sed command is actually the same as this sed command combined with this one, doing them back to back, basically. They're not semantically the same because they're filtering on different criteria. This one's looking for max and this one's looking for count. But in this specific instance, they process the same lines. And so that should actually be, yeah, that's good. I may not care that much about efficiency, but I may as well spend a little bit of time trying to make this not horrible. Particularly since it's going up on the internet and you guys can be very judgmental sometimes. Okay, so that does that. And now we'll go ahead and do this command next. So this is putting those header fields back on. And actually, if I really wanted to, no, I'm not going to bother. I was going to say I could actually most likely merge this and this together too. Actually, no, that shouldn't be too bad because what I can do is this. Probably not easily anyway. So I was thinking of trying to merge these two into one pipeline as well. The problem is that whenever you have multiple files, multiple input files, like these two commands have two different input files, dealing with one pipeline that processes multiple files and interleaves them and such can be a little bit tricky to manage. So we'll leave these as separate files. This guy's going to take type 1 as its file input to get the columns and then paste those onto type 2. And I'm actually going to, I think, just use Sponge to allow me to write that directly to type 2 without needing an intermediate file. Sponge is a command that's in, I believe it's more utils. And what it allows you to do is output to the same command that, or output to the same file that you're inputting from. The problem that this is solving, as a matter of fact, I think I don't use a redirect. I just do that. The problem this is solving is that whenever you do an output redirect, so say you have a command that takes in a file and you want to process the file and write it back to the same thing, which is a fairly common thing. Quite often people will accidentally do this with sed, for example, to do an in-place replacement on a file. The problem is that whenever you do an output redirect like this, it truncates this file first, which means that then your command is reading a file that is empty because you truncated it. So what Sponge basically does is it just absorbs, as the name would suggest, all of the output from this command first, and then writes it to this file. So that should allow me to not have to deal with any additional intermediate files here. Let's go ahead and run this and just verify that it's doing what we think that it's doing so far. So I'll go ahead and get rid of these type 1 and type 2.tsv files and run the script. Sed can't read no such file or directory. Okay, we got a problem. Is it... Yeah, so we'll run it in debug mode, and I think I just missed a file on one of these sed commands. Yeah, if you use this TACX whenever you run the script like this, it'll run it in debug mode, so it will tell you the lines is there that it's executing. $1, right? I missed a $1 here, like that. Okay, that stuff all ran, although it looks like we still got a problem with those two seds. Oh, right. Yes. I'm sorry. Of course we're getting a problem with those two sets because I'm not running this with an argument. There we go. Okay. So let's verify now that type 1 was produced and has the stuff we want. And type 2, good. Perfect, perfect, perfect. So we've done that processing. And so the next thing we need to do is get these split out into different files. So I think I'm going to create a variable called I. We'll replace this cat with actually reading type 1 as file input directly. That should be good. That should be good. We'll want to do that for type 1.tsv. And the same command, the exact same sed command should also appropriately process type 2. So that should do that. As far as the file name goes, we'll use this I to get it. So this is going to be one series $i.tsv. And this one should be 2, because this is file 2, $1.tsv. And that should actually be $i, not $1. And we need to increment I, just like that. And I think that should do it. Let's give this guy a shot. Same problem. Did I neglect to put file names again? No, I put file names. Oh, I didn't put a file name when I ran it. There we go. Okay. And that gave us our files. So those are all there. Okay, so cool. So now if I just run my GNU plot script as it is and take a look at the output of that. Is that plot1.pdf? Did it work? Do I have a PDF? I do. Looks like we got our plot. Sweet. Okay. So the rest of this is just going to be a question of automatically generating that plot script, which I should be able to do based on the I value and a few other things. We're looking pretty long on this, so I'm going to not do that in this video, although, as I mentioned, I may do a follow-on video where I do all the plotting stuff. But that's not as much scripting as the rest of this. So just to quickly summarize, what we did is we wrote a script using GNU Core Utilities, which gets us from this file format to a bunch of individual files that are set up, segregated out based on this number here and this number corresponding with their associated series number and x-axis value, so that we can easily generate the plot. This is the sort of thing that was taking me a couple of minutes to do manually, either by creating those files manually or even just when the first couple times I did this, I just used a spreadsheet. In either case, I've now gotten a script that will basically instantly create these files for me. And with a little bit more work, I'll be able to instantly create the plots as well. I hope that this demonstrates, if you weren't already well aware, just how useful Bash scripting is. Bash scripting allows you to automate some fairly complicated things pretty easily using just some very simple core utilities. I mean, perhaps some of this sed stuff is a little inscrutable looking, but it's actually not nearly as bad to write as it is to read. There's a common joke that regular expressions, which are what sed is based on here, is a write-only programming language. It's much easier to write it than it is to read it. And I hope that at least me talking through my thought process as I was coming up with these things helped a little bit. This whole back references thing is quite nice. I actually didn't know about that until relatively recently, and it's a very useful and very powerful tool for using sed. Without those back references, this is the sort of thing that I would have broken out awk to do in the past. But why use a full programming language when you can just use sed? Works pretty well. And as well as cut and paste are incredibly useful commands if you haven't heard of them before. There's actually another one which I didn't have cause to use here, but that goes right along with cut and paste, which is join, which is kind of like paste, except it matches up key values. So it'll paste the columns from a second file when a field on the second file matches a field in the first file. It's very much like a database join if you're familiar with those. If you think about it, you have sort, you have cut, you have paste, you have join. You can very easily do filtering using things like sed and awk. You can pretty much translate database queries into Unix commands. And you can do a lot of really, really complicated data processing on just plain text files using those commands as long as they're formatted nicely. So the core utilities have a lot of power and utility built into them. Anyway, I've been rambling enough. We will cut this video here. So I hope that you found this interesting and useful. And let me know in the comments if you want to see what I come up with for automatically generating those plot scripts as well. I have a couple ideas for how to do it, but I haven't really sat down and thought about what would actually work or not. Hope that you found this interesting and useful. Let me know if you want to see more about the GNU plot side of this, and I will see you in the next video. Have a good one.